Hello, everyone, and welcome to this week's Jfokus Brown Bag Lunch. And today we have Stephen White here from Callista. He's going to tell us about the Android framework Jetpack Compose. And we're all very curious about this. It's not really my field of expertise, so I'm really looking forward to this. And I have also here Niklas Finne, who will help me muting you if if we hear your voice in behind everyone else, and also let you come in if you're late. So Stephen, why don't you start sharing your screen and we can get going with the presentation.
Yep, let's do that. There we go. Can you see my screen?
We see your screen and we see the correct page as well. So
good, right? Okay.
Please go ahead.
Great. Hi everyone. Yeah, it's beautiful outside, so it feels a bit of a shame to sit here and listen to me talk, but never mind. Here I am. I hope I can be as interesting as the sun outside. Probably not, but never mind. Okay, so yeah, I'm going to talk about, well, first of all, I'm from Callista. We're a consultancy company based in Gothenburg and Stockholm, actually. And I'm going to talk about Jetpack Compose, which is the new Android development framework for creating modern UI on the Android platform. My name is Stephen White. I'm living down here in Gothenburg. And I have a bit of before I start the talk, I'd just like to make a slight confession in the sense that this is very much from a React developer's perspective. So I'm going to be talking about Jetpack Compose, but really the point of the talk, or one of the aspects of the talk, is to basically show you how easy it is for a React developer to jump in to creating native applications with Android Studio and Jetpack Compose. But it's very much from a React perspective. So I will use the word React quite a lot, I think, but hopefully you'll be able to see the difference between React and Compose as I go. I've been developing for years, since 95 or something, very much a Java developer from the beginning. But I kind of hopped over to the front end about 10 years ago, maybe a bit longer, because of a growing love for JavaScript, funnily enough. So I've been kind of submerged in the React world for the last 6 years. I run the React meetup here in Gothenburg. We have over 1,000 members. Because of COVID, we actually haven't been running any meetups because it's we just haven't done it, unfortunately. But hopefully we'll start up soon again. But we normally run about 2 or 3 meetups each year with varying kind of content, probably similar to this kind of format, Jfokus. So, and for the last 3 years, I've been working with React Native. So, you know, it's been interesting to look at Jetpack Compose from a React Native developer's mindset, if you like. Okay, so let's start. So the agenda: what, why, when, what it is, why it is, and when it came into being. Then I want to talk about the React mindset, thinking in Compose, how we can apply this React mindset to Compose, thinking in React. You know, what's the normal kind of mindset that we have in React and how we approach a problem or a project, and then applying React to Compose. So using these methods, these terminologies to be able to build a Compose application, and then some conclusions. So I'll just show you a very simple Flickr application that I built with Jetpack Compose, just to show you, you know, the methodologies of how you build it, basically. Okay, so let's start with what. So Jetpack Compose is a modern toolkit for building native Android UI. It's built on Kotlin, which is very nice. It follows a declarative programming model. You declare the layout, look and feel, And then as state changes, your UI automatically updates. And then there's a recomposition algorithm, which basically takes care of deciding what parts of the UI need to update. Okay, so as state changes, the recomposition algorithm will basically go through the composable tree, work out what needs to be updated, what needs to be shown based upon the state, and then present that. And then there's Android Studio, which gives you a complete kind of ubiquitous environment to be able to build your Android UIs, which is really very nice, actually, and they've done a great job there, I think. So first of all, you download the Canary, Android Studio, and you can create a new project. You choose empty compose activity, give it a name, and then you can choose your API. And Jetpack Compose actually goes back to API 21, which gives you about 80 to 90% of device coverage, which is really cool. So it's not something that will just run on really modern flashy devices, but will run on old devices as well. So here you can see that in Android Studio, you get a bunch of composables set up, and then you're able to preview them directly, and then also visualize them in the emulator. And you kind of get all this for free, or there's not much setup at all. You just kind of get this from the get-go. And this is really nice if you just want to get started and start doing stuff. In React and React Native, there is quite a lot of fiddling to get to this stage. One would have to use like Storybook, for example, to be able to visualize your components, but you get this immediately, and this is kind of nice. So why? Well, the main reason in my mind is React and the declarative method that you use in creating your UIs. I really think they want to challenge React Native. React Native is basically beginning to sweep the market for mobile app development. A lot of companies that I speak to and a lot of people that contact me on LinkedIn are purely for React Native development jobs. And I think the main reason here is that you're able to target both iOS and Android directly just from using React. And actually, it's not just that. You can also target web, and you can target Windows, for example. I think Office 365, a lot of that is now actually been done in React or React Native, amongst other things. So React Native is really beginning to kind of take over the app market. It gives you a declarative UI, which is something very new for most Android developers. Faster iterations, improved testability, and I really mean improved testability, it's great. Improved code reasonability, so the ability to be able to actually make sense of what you're doing. It minimizes complexity and cost of change, and it draws from a huge community of, funnily enough, React developers. Because the methodologies or the way you code are very similar to React, I think there's going to be a lot of pollination from the React community over to Android now as a result of this, which we'll see in a bit. So the other thing is, well, the current architecture that we have in Android is a bit, well, how can I say, antiquated. It's something that, if you're a web front-end person, it's something that you would have worked with maybe with the old Knockout framework, or maybe even the old Angular framework, Angular 1 framework, in the sense that you have an MVVM architecture. So at the top, you have your view, which is normally in some kind of XML, which you could say is decorative, but it's in XML. And then this observes data from the view model. Okay, so basically each view would have a corresponding view model, which would be in Kotlin or Java. And this is the link between the view and the model, or the view and the view model. And then you would have a model, which is basically, where your application state is being stored, stuff that you get back from your API calls. And then, this is kind of sprinkled, this kind of state or this kind of data is sprinkled into your view model, and then your view updates. And then also you'll notice that you have double bindings. So, you know, whenever you update anything in your view, this can be automatically pushed back onto your model. So you've got this is the current architecture, which will, I think, change quite radically this year with Jetpack Compose of Android. And this is trailing behind. I mean, Swift UI has already adopted a declarative approach. Most new web frameworks no longer use this kind of architecture. And so Android basically has to do something about it. This kind of architecture is problematic in my experience. It leads to all kinds of complexities. And the main one being is two-way data bindings. You know, this is one of the main issues that I have with this. And I'll talk about unidirectional data flow a bit later on as an alternative. But the main thing is this business of coupling over cohesion. I mean, the goal in any kind of good software engineering is that we want to, or software design, is that we want to minimize coupling. We want to maximize cohesion. You know, this is kind of schoolbook stuff. We see this all over the place. But with the MVVM model, you know, we have huge amounts of coupling and very minimal amounts of cohesion. A lot of the cohesion kind of happens within, you know, maybe Kotlin business logic, for example. But you have this very brittle coupling between the bindings of the view model and the view. You know, and you can unwittingly remove something from the view model, and you know, if you're refactoring something, you might not see that is a binding into your view. So when you run it, you know, you end up with some kind of null reference exception or something. So what we want is that we want to be able to move to high cohesion and low coupling. And this is what Jetpack Compose tries to do. Now, you could say that we're kind of moving away from separation of concerns, in the sense that, you know, the XML was your view, and then the Kotlin model was your model, if you like, and now we're moving them into one thing, which is the composable. So the thing is that we have UI and logic all within the composable now, but this leads to very, very high cohesion. It means that we're able to see exactly what the logic is of the UI is, and then also we're able to see the UI as well. I mean, things like theming are normally abstracted out into this thing called a modifier or a theme as well. But basically, you have the same kind of model that we have in React, you know. And also we have a unidirectional data flow now. So we have state, which is further up, which comes down into your composable. And then we have events that go up, go up, and those events will mutate the state, and then the state changes will then trickle down to the composable again. So it's a unidirectional data flow, and you have high cohesion and very loose coupling, low coupling. So this leads to good code reasonability, testability, faster iterations, and in my mind, minimizes complexity and cost of change. The testability aspect here is enormous, and it's something that kind of drew me to React initially, and now we have it in Compose. You know, it really gives you the ability to do TDD right from the get-go, which is great in my mind. So separation really was always an illusion, because although you had the XML and you had your model, in fact, they were so tightly bound together that there was no separation, you know. And if you take that to the web, you know, where you have the argument of CSS, contra HTML, contra maybe a controller or something, all of this stuff is so tightly connected that there is no real separation. It's very much coupled. And this is the whole deal with using component-based frameworks, component-based declarative frameworks like React or Compose. So when did this appear? Well, Google were kind of on the lookout for something, I think, already back in 2018, and they launched the Jetpack suite of libraries, which basically gives you a bunch of really sweet libraries to aid in your Android development. But Compose launched Google's I/O developer conference in 2019. And since then, we've had a bunch of betas, developer releases, alphas, and now finally we moved on to some betas. As of March 2021, we're on beta 2. When I first gave this presentation, we were on alpha 9, so there's been quite a lot of traction here. And this is really nice because this is the kind of traction that I experience in the JavaScript world. You know, things are really moving fast, and there seems to be a lot of impetus in getting this out, you know, which is great. So there's definitely longevity here, I think. And I have to mention a guy called Leyland Richardson. He originally was from Airbnb. He was a kind of superstar in the React world, creator of a testing library called Enzyme, which used to be the de facto testing library that we used in the React world. But when Airbnb said that they were going to ditch React Native and go over to doing native apps, he left and ended up at Google, which was quite interesting. He used to head the React Native development at Airbnb, but he left that, went over to Google, and then all of a sudden Jetpack Composer arrived. But it wasn't really all of a sudden, because at that time also he gave a few talks regarding, wouldn't it be nice to be able to do React in Swift or in Kotlin. So he gave a few examples of using the React kind of model using Kotlin or Swift. So I think, you know, the Compose project was very much in his mind when he went over to Google. And it wouldn't surprise me if he was one of the main instigators there. But from a React developer's perspective, it's great to have Leyland on board, you know, because he was a real, you know, he gave so many talks at so many React conferences. So it's great to have this superstar here, which is good. So the React mindset. Well, composable functions, state. The UI is a visual representation of state. And this is something that is very integral to the React application, to a React app. We're not just building a GUI, a UI. We're building a state machine, a visual state machine. There's testability. We have the testing framework here from Ken C. Dodds, which seems to be the de facto testing framework that we use in React now. There's effects. React went from using component-based or sorry, class-based components to using functional components, or functional components have been around for about 5 years now, I think, but they're basically heavily invested in pure functional components. And then you use effects to be able to sprinkle in side effects into your pure functions. You know, and these side effects can be things like calling an API. It could be reacting to a property change or a state change. It could be injecting state into your component. But basically, hooks are a really integral part of a modern React application. And in Compose, we have the comparable amount of hooks or effects that we can use in Compose. And then also styling, so style components. So these, you know, when I approach React, this is what's in my mind. You know, this is what comes up: composable functions, state, test, effects, and styling. And this is something that we can take directly into Compose. And then also, obviously, we have the declarative API. We have our effects. So I have my use effect here, for example. And this will basically run this little function, this lambda function, whenever the count state updates. And then we have our button, which is a bit of declarative JSX. So whenever we press the button, the count updates, or the count state updates, then it will feed back here. And then also we'll run this little piece of logic. So whenever the count goes above 5, we just reset it back to 0. So, you know, JSX, declarative, effects, state. So thinking in Compose. Hang on a second, just a bit of water. So again, it's declarative. So this is a counter button. This is kind of a similar markup to what we saw previously. You have mutable state. So we have our count, set count, which is pretty much the same as we had previously. We have a modifier here. Now, Jetpack Compose uses this modifier to be able to sprinkle in your theme and a bunch of other things as well. But I won't go too deeply into that. And then we have our outline button. And you can see here, instead of using XML or JSX to be able to define your component, we can use functions. And this is a bit of a step in the right direction. And to be honest, it'd be nice if React moved away from JSX at some stage in the future. I think if you use Kotlin JS or even Scala JS, there are React implementations which use exactly this kind of style in building up GUIs, which is kind of nice. And you can see that we have some properties on the outline button, the on-click event. We have some border, shape, and then we pass in the modifier. And then obviously this can compose other composables. So this text composable is another composable. So we're composing composables, so on and so on and so on. Okay. Also, we have the ability to be able to preview this. So we can do this in Android Studio. And you can see that we can basically preview this button directly. And we can also preview the state that's happening, that's being updated, which is super nice. Composable functions. And then we have, so you can see that we've got a bunch of counter buttons here, and they all have individual state. But then also we can move that state up into another composable. So in the React world, this would be known as like a container pattern that we would use. So the container would contain state, which we pass down into its child components, or in this case, composables. So data down, events up. So the data is flowing down, and the events, as in the clicks, are flowing up, mutating the state. So the count state is going down here, and then we pass down the set count function, which is being called in the outline button on click. And you can see that whenever we click on one of these buttons, the state is updated for all of the buttons. Okay. So also we have dynamic content and logic. So this means that we can basically sprinkle in logic directly into our composables. So if count is less than 5, we choose a different color. Else we just choose the material theme primary color. And then also, if you remember the use effect hook that we had previously, we have this on commit effect. So whenever count changes, the lambda function inside here will be called. So if count is greater than 2, we set the scale to 1, set the count to 0, else we just increment the scale. So you can see here that when I click on the button, the animation effect is happening, is coming in and out there. Okay, and then recomposition. So this is the algorithm that basically recomposes your composables. So should we call the functions ourselves? Is everything redrawn whenever you change some state? No, it's not. Basically, the recomposition algorithm just takes care of this, and you can just leave that. But essentially, whenever state changes, the UI will update. So that's the main thing you need to have in mind. But also, one of the differences between React and Compose is that it runs in parallel, which is kind of sweet. So, if you look at this, you would think that this would render, then this would render, and then this counter would render. But no, it could be the case that these render in a completely different order, depending upon what the threading mechanism is doing. And then testing. So, we apply a modifier, we apply a test tag onto your outline button, counter ID, for example. And then within our test, we can get that button, and then we can begin to assert things. And then also we can click. And when you click, the internal state or the state of that particular button will update. So here you can see this in action. And this is real time. I think if you have a test suite set up, oh god, well that happened very, very quickly actually. But basically what happened there is that we loaded up a couple of buttons, clicked, and then we just asserted that the text change was happening. And this is really nice, and the tests are just very, very simple. You declare your UI, set up a test tag, and then you can just assert some stuff and perform clicks and things, which is nice. So thinking in React, this is actually taken from React's documentation, really. But in a way, this is something that, if you haven't read the documentation, it's something that you just kind of begin to get used to, or it's something that just you have as a template in your mind as you're creating your React applications. So the first thing is that you start with a mock UI and data. So this could be like some kind of Figma or Sketch image or something, and then you want to break your UI into a component hierarchy. So again, it is a hierarchy. It's a tree of components. So for instance, with Compose, you would have a main activity. You would have your layout. Maybe there's a header, there's a body, there's some tabs at the bottom. Think about a mobile app here. There's search input. This is for the Flickr browser. There's a loading spinner. There's a photo list, photo row, image, header text, date, photo details, and image, and so on and so on. But this is really nice because each one of these is a composable. Each one of these is broken down into smaller composables that you can test and you can verify as a unit, which is super, super nice. And this is something we're used to in the React world very much so. But in Android, this is quite new, really. So then build a static version in Compose. So, don't have any state or anything, or maybe have minimal state, but just build up your basic components. So, we have a list, we've got the list items, there's some text here, the search box. Just build something static so you can see how all of the composables kind of fit together. Then we want to identify the minimal representation of UI state. Now, state is something that we can talk about, but basically start with the minimal UI representation of it. So in our case, the search input obviously needs a place to hold the search text. It needs a place to hold the loading Boolean variable, for example. It needs a URL for the image. It needs a header text, date, photo item, photo list. So this is state. This is stuff that's going to be feeding these visual components. And then we need to identify where the state should live. Should it live near the component, or should we move it up, or even outside? Okay, which we're coming to in a sec. So in this diagram, I've just moved it up. So we move all the state into a view model up in the main activity. And then this state is kind of fed down, trickles down through our component tree into whatever component needs that particular state. So, the photo list goes down into the photo list component. Search text goes down into search input component, for example. But then you need to be able to update or mutate the state. And you would do this via functions from the view model. Okay, so for instance, on search Flickr. So whenever you type some stuff into the search input, this function is called, which will then update the search text. Okay. So an inverse data flow, top level component passes callbacks to child components to mutate the state. And that is kind of what I was showing earlier. So, the data flow comes down, but you mutate the state by passing down the functions, but those functions will mutate the state further up in the hierarchy or wherever the state is. Okay, so there you go. So the on search Flickr ends up in the view model. But then also I talked about having a state outside. And in Jetpack Compose, there's a really amazing, there's a beautifully named thing called Ambience. And this is where you have global state. In the React world, we use the context, which is maybe a bit kind of context-like. And I really like the word ambient. So it's ambient state, which sits around, maybe it's globally, maybe you can attach the ambience to your main activity, but you can also attach individual ambience to wherever in the component hierarchy. So for instance, if you wanted to apply a different theme down here, you could do that, And what this means is that wherever you apply the ambience, maybe up here, it means that any of these components can get access to the view model and get access to the current state in that view model. Okay. So applying React Compose. Okay, time's marching on here. I'll quickly go. So what I'll do is just run you through the basic project setup that we have for the Flickr app. So, here we are. This is a bit of a screenshot from Android Studio. We have our API. This is the thing that's communicating to the Flickr API. We have our composables, counters here from the examples I've shown from the presentation. But you have your layouts, photo details, photo list, photo row, search input text. So these are your composables, if you like. And you can see they map to that composable hierarchy that we had earlier. And then we have our model. And one of the nice things with Kotlin is that we have our data objects. So we can basically we can fill up the data objects directly from the API through JSON, which is nice. And you have typed data, which is kind of a bit of a plus compared to JavaScript. But you can, obviously if you're using TypeScript, you get typed stuff, but here it's really typed, which is very nice. And then we have our view model. So looking at the main activity, this is where we're kind of feeding or setting everything up. And this is the main entry point that you would set up in your Android manifest.xml. So you can see here that I'm instantiating the Flickr view model. And then on create, this is another effect. And basically this will be run when the composable or when the main activity is first created. And the important thing is that we're wrapping our there's a bunch of composables that are kind of wrapping each other here. And we have, well, let's start at the bottom here. We have the layout Flickr, which is basically the top of our composable tree, which is here. That's the main activity that we were before. So the layout activity, or the layout composable. But then we have a provider, and what we're doing here is that we're providing the layout composable with the Flickr view model. So we provide that in the ambience of the app to the layout Flickr model. So that anything under the Flickr model can have, anything under the layout Flickr composable can have access to the Flickr view model. And then we've got the theme, which we're applying to the whole app as well. And theming is one of the really, really nice things in Compose. And you get this right out of the box. Theming in React can be a bit of a headache at times, especially if you're creating your own design system. But here, basically we're just adhering to Material UI, which basically, alleviates a hell of a lot of arguments regarding spaces versus tabs, for example. You just get Material UI and you get it out of the box. And, you specify your colors, your typography, your shapes, and then you knit this all together in your theme, and you can see here, this is the theme, and this is where we knit these all together. So we create a material theme, and then we knit this together. And you can see that we can also have a dark or a light theme. So dark mode, light mode. And you get this from the get-go. And again, we have some logic sprinkled into this composable, where we can switch between dark or light mode. So having a quick look at the view model, we have our photos. Again, it's using this mutable state of, which is new in Jetpack Compose. We have our search text and we have our loading Boolean. And then also we have our function that we're calling the onSearchFlicker function, which you can see updates different aspects of the state. So updates loading for true. Then we're launching, so we're using Kotlin's coroutines here, which is very nice. We can use those directly out of the box. We're scoping it to the view model, so it's the view model's thread, if you like. And you know, we call our API. We get back a bunch of photos, and these photos will be typed and in a photo response, you know, which is nice. And then eventually, when this is all finished, we then set loading to false. Actually, that's in the wrong place. That should be there. Never mind. And in the view model also, I'm specifying my ambient, which we were using earlier. And then you can see it provided. And then on active. So as soon as this is on active, is another effect that we can run. This will be called as soon as this is the first time this is rendered, if you like. So this is only called once, and the callback that we're passing in here is a search for Rocket. So we're searching the Flickr API for Rocket. Okay, I'll hop over this actually quickly. Data flow. Or maybe I can just go through it very, very quickly. So for those of you that aren't used to React, maybe this is kind of simple, but it's interesting because it gives you an idea of the basic data flow of what's happening. So number one, if we start here, what we're going to do is I'll take you through what happens when you type some text. Okay, so you type some text, and the text file, which is some state, will change. Okay, and so whenever that text changes, number two, the onCommit effect is called, or the lambda within onCommit is called. So this will call the onSearchFlicker. So this will fire off an API call. Okay, so down here, number three, loading will be set to true. So as soon as the state in loading is set, the view model will whatever's listening to loading or whatever's being referenced by loading will be updated. So there's a reaction, if you like. So this loading property that I'm sending down into the search input text will get updated with a new loading value. Okay, and as a result, that will come down into the search input text. The loading, this little piece of logic will be called. Loading is now true, so the icon with the cake icon will be shown to show you that you're loading. Okay, and then loading is set to false, and then the cake icon goes back to unfilled. Okay, and then to show you all of this, tested, as it were, you can see here. So what we're doing is that we're testing typing in some text. You can see that the cake icon will change, and then the tests will pass in this sense. So we type in something, we update the state, and then you can test all of this really, really nicely. Also, we have the ability to be able to preview this. So with previewing, we're able to pass in different pieces of state into the particular component that you want to show. So for instance, you know, this is the basic component that we have. So this kind of like, this kind of color here is just from the base material UI color. And then we can come down and we can see that when we apply the Flickr browser theme, we get a completely different color. And so on and so on. And also with the cake icon, for instance, well, not pass, loading is, you can see is false here, loading is true here. So you can see all this directly in Android Studio, and that's nice. You know, that's really, really good. So you can really get into this TDD kind of mindset when you're running, when you're developing with Compose. You know, you can test, you can code, you can preview, and then you can emulate it directly within Android Studio. And from a developer experience perspective, this is great, really. You know, yeah, you just can't do this using the MVVM approach. So here is the Flickr app that I built. So you can see that it's just a list, and then, you know, we can just click on an item, go into some details, and you can see that, you know, we've got nice smooth scrolling. You know, getting smooth scrolling in an app is super duper important. You know, we can type stuff in, and yeah, I don't know, I just really enjoyed this. And then you can just, here we're just searching for a nebula. And this obviously is going towards the Flickr browser, Flickr API that I've got set up. And then we can click on details here. I think it's running a bit slowly because of Zoom, actually. The Zoom thing. It's always a bit slow. I'll move it up. There we go. So conclusions. In my mind, I really think Google have nailed this. Seriously, you know, I really think they're going to lock over a lot of React developers. I do spend a lot of time as a React native developer doing a lot of weird fixes purely for Android. Everything is not as smooth as the React Native teams say it is when we do stuff in Android. Funnily enough, React Native works really well on iOS, but on Android there are a lot of weird things that we have to do to get it working. The React developer adoption. You know, as a React developer, it was really easy to come in here and just feel at home. You know, there's a comparable amount of hooks with effects that you just learn and just get used to very quickly. It's using Kotlin. Kotlin is a really lovely language to use. You know, I really think they're moving ahead here with Kotlin, and that's great. Developer experience was amazing. You know, really good. You know, you get preview, you get testability, you have the emulator, everything's there at your fingertips, and not much to set up. You know, everything's just kind of there immediately for you in the IDE, which is nice. The animation API is great, actually. You know, you can do transitions based upon state changes, and I really like this. I mean, there are animation frameworks like Reanimated, which I use extensively in, especially Reanimated 2, which I use extensively in React Native. But it was just really nice to have all this at your fingers without having to bring in a new library and stuff. And theming, I just love the fact that they've just chose Material UI, and you can just get on and do it. You know, it's really good. Compilation is a bit slower. Obviously, React uses JavaScript, which is a just-in-time kind of compiler, if you like. So, you know, there's a faster turnaround. There is a faster turnaround with React and React Native, but the compilation was actually pretty fast, you know, in comparison to what I've known previously. So that was good. And then I've collated a complete list of hooked Compose comparisons on the GitHub site, which maybe we could post up on the chat afterwards. So you can have a look there if you're interested to try this out. Okay, so that's it.
Thank you, Stephen. Thank you very much. I'm gonna turn off the recording, and then we're gonna go over to some Q&A. So bye-bye, everyone there.